Hello everyone, happy Friday. So, one problem again today. It's going to take us the whole time. If you haven't figured out by now, that's just kind of how dynamics goes. So, we know that at the instant shown in this system, bar AB has constant angular velocity of 10 radians per second in the clockwise direction. So then the question asks, determine angular acceleration of bar BD and DE. So, how I always start these things is I'm immediately told what I need to find. So I need to find angular acceleration of bar BD and then angular acceleration of bar DE. So, starting with the first bar, I'm going to write the base dynamics equation that follows. So here we have acceleration of B equals acceleration of D plus angular acceleration of bar BD crossed with the position vector with B with respect to D, and then minus the angular velocity squared of BD times the position vector again. So does everyone recognize this equation?
Yep.
Yeah, we've gotten there? Okay, great. Okay. So, how I normally do these things, I do not know the acceleration of B. I do not know the acceleration of D. I don't know the angular acceleration of bar BD, but that is half the problem, so it's okay not to know that. So I don't have colored markers anymore, but like these ones would be the red question marks, and then this one would be the green one, how I color code. That's okay not to know. The position vector, B to D, I don't have it yet, but I can get it really easily. So it is a known, you just have to do the work for it. I do not know the angular velocity of BD. And finally, I don't have this yet, but I can get it. But it's pretty clear looking at BD, that bar, that we are missing way too much information. What's up?
Is this equation expressed in terms of in terms of vectors or scalars?
Vectors.
Okay.
Yeah, they have directions to them. So, I mean, you could really say this is, so acceleration of B in the I plus acceleration of B in the J plus acceleration of B in the K equals this entire thing.
Okay.
And you could do that for all of them. All right, so it's pretty clear that we looked at bar BD and applied this base equation. And I applied that equation because this is the variable I'm trying to solve for. And I knew this equation would have this variable in it. But it is nowhere near ready to be solved yet. So I found out all I can from bar BD at this point. I'm now going to look at AB. And the reason I'm going to AB is because I know something already about A. The acceleration of point A is 0, the velocity of point A is 0, and one other thing. Bar AB has constant angular velocity, which means the angular acceleration of AB is 0, and I'm given the angular velocity. So from the problem and looking at the system, I know a lot about AB and A itself. So look at bar AB now. All right, applying this exact same equation, but just with different points now. acceleration of A is equal to the acceleration of B plus the angular acceleration of bar AB crossed with the position vector from A to B. Everyone good there? Just same exact equation, just now I'm looking at points A and B. So, acceleration of A is 0 in all directions. Let's see, what else? Actually, I'm just going to acceleration of A equals 0. I'm told that the angular velocity of AB is constant, so alpha AB is also 0. So this entire thing goes to 0. So what do I have now? The problem gives me angular velocity of AB, so I have that term right there. And then the position vector, A with respect to B, I don't have it yet, but it's easy to get. So in this equation, I have 0 equals acceleration of B minus I know this, I can get that, I don't know that. One equation, one unknown. After I get the position vector, I can solve this and find the acceleration of B. Now, why would I want to find the acceleration of B? That was one of the unknowns in this first thing that I started with. So, by looking at bar AB, I'm about to figure out something about the equation that will solve the system, right? So now I'm going to go ahead and solve for the acceleration of B. So the position vector, A with respect to B, it is 2A from B. 2A from B, so that is 20. So 2A from B, 20 in the I, and 40 in the J. Any questions there? All good? Okay, awesome. All right. So we can solve for the acceleration of B. Acceleration of B equals 10 Okay. So now I have the acceleration of B. So coming back to this equation, I'm just going to write it again. Acceleration of B equals acceleration of D. Still don't know this. I can get that. I can get that. Don't know that. Have that now, but I don't know that. So we still have some work to do, but we are making progress. So that's good. Okay. So next step. When I was doing this, I kind of just randomly chose, well, not randomly chose, but I chose that I wanted to try to solve for this term next. So that's where I'm going. So solving for the angular velocity of bar BD. Base equation, velocity of B is equal to the velocity of D plus the angular acceleration of bar BD crossed with the position vector. I don't have velocity of D, can get this. I'm trying to get angular velocity of BD, so that's okay, but I still don't know velocity of B. But I'm stuck looking at bar BD, so what I'm going to do now, I'm going to jump back to bar AB. And when you're solving problems like this, you're going to do this all the time. You're going to look at one part, you're going to get stuck, jump back to another part, do everything you can there, get stuck again, go back and forth, back and forth, back and forth. So I started at BD, jumped to AB, found something out about bar BD, got stuck again, so I'm jumping back. All right, so looking at bar AB again. Is everyone cool if I get rid of this part?
Yeah.
Yeah.
In terms of the easier load up the amount of work that you have to do, is it best to do the velocity analysis first, or velocity acceleration both hand in hand?
It's different for every problem, because yeah, I really can't give you a concrete answer there. I mean, like some people, what they do is solve the position vectors first and just get all those out of the way, and then they go velocity and then acceleration. I like to do it like how I write the base equation so that it guides me for where I need to go.
Okay.
So it's like a roadmap. That's my best way of doing it. If you just try, solve, you're constricting yourself if you say, I'm doing velocity first no matter what, and then I'm doing acceleration first no matter what. I mean, you could definitely get it to work, but yeah. All right, looking at bar AB again. All right, velocity of B is equal to velocity of A plus the angular velocity of bar AB crossed with the position vector B with respect to A. So velocity of A equals 0. A is the pin, it's not doing anything. So now we do know this term. We're given the angular acceleration of AB, so I do have that. Position vector B with respect to A, I might have already solved, yeah, I did already solve for that before. But even if I didn't, it's super easy to get it. So, one equation, one unknown, I can solve for the velocity of B. And why would I do that? Because I got stuck here trying to solve what the velocity of B was, right? So, that's why I'm even doing this in the first place. So, let's get the velocity of B. Velocity of B is equal to 0 plus, it's given as 10 radians per second, 10 in the K, crossed with the 2B from A. 2B from A. So that's actually opposite. Yeah, that's opposite.
Would the K vector for the angular velocity be negative because it's moving counterclockwise? I mean, sorry, clockwise.
Yes. Yep, you're right. Yep. Okay. So now it's just cross product. I, J, K. If you haven't seen before, how I do this is so this is K cross I. K cross I is J, and because it followed my little schematic, it's positive J. So velocity of B equals Any questions there? Just cross product and computation. So velocity of B, now I have that. So back to this equation. I know this now. What do I still not know? Still don't know angular velocity of BD, and I do not know the velocity of D. But we're starting to fill in these unknowns. So, everyone cool if I erase this? All right, so in my original problem, so this is just what I erased on the board, but I just wrote it smaller to make more space. But I just saw velocity of B. I do not have velocity of D. I do not have the angular velocity of it, but I can get the position vector. So once again, I'm stuck. Okay, now we're going to look at a different bar. The only one we haven't looked at yet. Look at bar DE. So applying this same velocity equation, the velocity of D equals the velocity of E plus the angular velocity of DE crossed with RD with respect to E. Okay. Velocity of E, 0, because it's the pin, right? So that's 0. I don't know velocity of D, but that's okay because I'm trying to solve this problem right here. I do not know the angular acceleration of DE, and the position vector, I don't have it, but I can get it pretty easily. So, the position vector is D with respect to E. So at this point, it's still 2 equations and 2 unknowns, but I'm going to do something that I haven't done before yet. I'm actually going to solve velocity of D in terms of the angular velocity components. So to get back to the question you had in the beginning, actually, if you want to go like position, velocity, acceleration, that's perfectly fine. You would, if you wanted to use that method, you really wouldn't treat any situation as getting stuck like I do. You would solve everything in terms of like what you have. So what I'm going to do is I'm going to solve for velocity of D in terms of the angular velocity of DE, and then stick that into this equation. And that's how I'm going to solve it. So, okay, velocity of D is now equal to velocity of D in terms of the angular velocity of bar DE. All right, so I'm gonna jump back one more time, going back to bar BD. Everyone good if I erase this? That equation again, velocity of B equals velocity of D plus I have this. I just solved for the velocity of D in terms of angular velocity, so I still really don't have it, but I'll show you what I'm going to do with it. Don't have this, and I can get that. All right, velocity of B. Velocity of B, I solved it earlier as to B from D. Okay. So this is what we have here. So you might be tempted to say, okay, it's one equation, two unknowns, because DE and BD, but it's a vector equation. I have I and J components. So really this equation is two equations, and three even if you want to consider the K direction. But so how are we going to do this? Once more, I'm going to evaluate this cross product first. So all right, so this is what I have thus far. So if I look only at the I components, I have negative 400, and the I is equal to 25 angular velocity of bar DE in the I, and nothing else. So it really looked like there was two equations and one unknown, but I can actually solve when I split it into I and J components. Does that make sense?
So it's just ending with a system of equations?
Yes.
Okay.
Yep. So now I can get angular velocity of bar DE is just negative 400 divided by 25. So angular velocity of DE is equal to negative 16 in the K direction. Now that I have that, I can definitely solve for BD now, right? So is everyone good with this? J components of that same equation right here. So that's 200, and the J is equal to 20. Okay. That's what I want. I have that, so now it's just computation. Everyone with me here? Okay. Basic algebra at this point, and you get the angular velocity of bar BD is -13 in the k direction.
Would it be rotating clockwise for both linkages DE and BD?
Yes, because that's how I solved it.
Okay.
Yep. Or that's how I defined it. I defined positive was that way. So it was counterclockwise, so yes. All right. So at this point, we have definitely gone on a tangent, and you might get lost, like, what are we even doing? We're like so far away from even what we were trying to do in the first place, is trying to solve for the angular velocity of BD. But along the way, I found angular velocity of DE, angular velocity of BD, acceleration of B. So I'm going to write out the first equation that we had, that I wrote down, and then show everything we've solved for thus far. It would make a lot more sense if I had infinite room, because I would, keep saying I'm doing this because I'm trying to solve this thing. So that's why I think, when you're doing these problems on the test, you are going to have more room than I have right now. So, that's why I recommend using my method of like the checks and the question marks, because it'll guide you. It's like a roadmap for how you're going to solve this problem. But yeah. Everyone good if I erase this? Yeah, cool. All right, the first equation we started with, acceleration of B equals acceleration of D plus angular acceleration of BD crossed with alpha, or angular velocity of BD minus BD squared. All right, so if you remember, when I first wrote this, we had so many unknowns, but I solved for this. Still don't have acceleration of D. Acceleration of BD is the whole point of the problem, so that's okay not to know. I found that, oh wait, that's a typo. But still, I still have that. Have that, have that. Any questions? So the first place we started, there were so many unknowns, and now I'm only down to 2 unknowns, but really one unknown, like one unknown that I care about, because I'm okay with not knowing this, because it's the whole point of the problem. I still have to get the acceleration of D to solve, though. So, how am I going to do it? When I initially solved for, in the beginning, I solved acceleration of B. It was okay. Any questions here? The position vector B with respect to D, that's just, this right here only has I components. So, yeah, I'm going to now do some cross product, and then I'm going to split it into I and j components, and then see where that brings me in terms of what I know and what I don't know at that point. All right, now just looking at I components. 2,000 in the I direction equals acceleration of d in the I direction minus a constant. Any questions there? So this is similar to last time. I had an equation and it looked like I couldn't solve it because too many variables, but I broke it into I and j components. And when I look in just the I direction, it turns out that I can solve for the acceleration of d in the I direction. I still don't have the acceleration of d in the j, but this is helpful. So just algebra at this point. Acceleration of d is equal to, what is it? 4760. All right. So almost there to solving this. I have half of the acceleration of d. I need to solve it in the j direction too. So looking in the j now. This equation right here. 4,000 the j equals acceleration of d in the j direction minus but still don't have this, and I still don't have this. So unfortunately, we need to look at another bar. Is everyone good if I erase this? We're almost there. Almost there. Look at bar DE again. Acceleration of D equals acceleration of E, which is 0, plus all right, so acceleration of d, I have it in the I component, but not the j. So I'm going to rewrite that as, we found it in the I to be this number, but I don't know what it is in the j. Alpha dE, this is actually the second part of the problem. So it's good that this variable shows up. So this is the second part of the problem. D with respect to E, the position vector, I can get that. I solved for the angular velocity of dE, have that. I can get that easily. So, all right, I am going to break this into I and j components again because I'm trying to solve for the acceleration of d so that I can stick it back into the base equation and get the angular acceleration of vd. All right, I direction now. And as it turns out, if you remember last time I said usually the problem's given in order of how you should solve it, I actually solve for DE first, and it's because before I solved almost literally everything else you could have needed up until that point. I didn't like use the way the textbook tells you to do it because I thought it was a little confusing, but yeah. Okay. So, I is equal to So I got a little ahead of myself. I don't ever want to skip the cross product when I'm doing it with you guys because it's like a very important part. So now I'm going to split it into I and J components. All I did was compute the cross product. So now I have the entire thing and I and J components of this big equation now. I first. So we have one equation, one unknown. I can get angular acceleration of bar dE, which was actually the second part of the problem. So 1/2 of the problem's done. I just didn't do it in order. But it doesn't matter because we're solving the problem anyway. So just basic algebra at this point. What it ends up being is 14.4 in the positive k direction. Any questions? Okay. Now, j direction. Acceleration of d in the j direction is equal to I just solved for that. Now I can get the acceleration of d in the j direction, and then I'm going to use that to solve the acceleration, the angular acceleration of bd. So acceleration of d in the j direction equals 20 times 14.4 plus 6,400. Do the computation. Acceleration of d in the j. So acceleration of d in the j is equal to 6,688. And there was also an I component. So the I component was this part right here. So I just solved for this. Okay. All right. So, last step, we have everything we need. Everyone's good if I erase? Last step, and it makes sense. Look at BD one last time because that's where we started, right? So, it was acceleration of B is equal to the acceleration of D plus alpha BD cross RB with respect to D minus D. So the first thing I started with, calculated this a long time ago at this point. I just solved for all components of the acceleration of D. Now I have that. Angular acceleration of BD, that was the whole point of what I've been doing for the past 50 minutes. And it just happened along the way. I happened to solve for DE, but I started with the motivation of trying to solve for this. I can get that, and I definitely have the angular velocity of BD. Now I can solve. So, writing everything out. Does anyone remember what I had for angular acceleration of BD on hand?
Angular acceleration.
It's 16 or 13.
It's, you said it was negative 13K.
Negative 13. All right, so this leaves us with so this is acceleration of B. Acceleration of D was I just solved for. So now we have K cross I, J, and then this term right here is just a constant and it evaluates to, and it's in the I direction, and it evaluates to minus 6. So, the base equation I had, everything now in terms of numbers, all I have left is angular acceleration of BD in the J direction. So, looking at this, you could split it into I and then J, but looking at this variable that I'm trying to solve for, it's only in the J. Like everything else is just in terms of numbers, and this is all I need to solve for. So, last step is splitting this equation into J direction. Okay. 4,000 equals 668 minus 40. That's the equation. J direction, algebra, 67.2 radians per second squared in the positive K direction. That's it. Does that make sense? So, that's the final answer. All right, thanks for listening.